Good day everyone. Today I will be discussing to you the trigonometric equation. So to solve a trigonometric equation, use standard algebraic techniques such as collecting like terms and factoring. So the goal in solving a trigonometric equation is to isolate the trigonometric function in the equation. So for example, solve x in the equation 2 sine x is equals to 1 at the interval 0 to pi. Divide each side by 2 to obtain sine x is equals to 1/2. So the solution are x is equals to pi all over 6 and x is equals to 5 pi all over 6 in the interval of 0 and 2 pi. The general solution are x is equals to pi all over 6 plus 2n pi and x is equals to 5 pi all over 6 plus 2n pi. Sine x is equals to 1/2 has infinitely many solution. So any angles that are conterminal with pi all over 6 or 5 pi all over 6 will also be solution of the equation. So when solving the trigonometric equation, write answer using exact values rather than decimal approximations. So the solution of a trigonometric equation is the value of the angle that makes the equation true. If the derived value of the angle does not make the equation true, then it is an extraneous root. In solving trigonometric equation, it is advisable to express the given equation in terms of one trigonometric function only. So example number 1. Factoring an equation of quadratic type. Find all solution of 2 sine to the power of 2 x minus sine x minus 1 is equals to 0 in the interval of 0 and 2 pi. A solution. Begin by treating the equation as a quadratic in sine x and factoring. So 2 sine to the power of x is equals to sine x minus 1 is equals to 0. Where the original equation. So factor out 2 sine x plus 1, then sine x minus 1 is equals to 0. Setting each factor equal to 0, you obtain the following solution in the interval of 0 and 2 pi. Sine x minus 1 is equals to 0, then 2 sine x plus 1 is equals to 0, and then sine x equals to 1, then x is equals pi all over 2. So 2 sine to the power of 2 x is equals to negative 1 all over 2. So sine x is equals to negative 1 all over 2. So x is equals to 7 pi all over 6, then 11 pi all over 6. In degree, interval of 2, 10 degree, 3, 30 degree, and 90 degree. Example number 2. Using inverse function. Solve second to the power of 2x minus 2 tan x is equals to 4. Solution. Second to the power of 2x minus 2 tan x is equals to 4. And that is the original equation. So let's proceed to the Pythagorean identity, which is 1 plus tan to the power of 2x minus 2 tan x minus 4 is equals to 0. Then combined like terms, tan to the power of 2x minus 2 tan x minus 3 is equals to 0. Then factor, tan x minus 3, then tan x plus 1 is equals to 0. Setting each factor equal to 0, you obtain two solutions in the interval, which is negative pi all over 2 and pi all over 2. Recall that the range of the inverse tangent function is negative pi all over 2 and positive pi all over 2. So tan x minus 1 is equals to 0 and tan x plus 1 is equals to 0. So tan x is equals to 3, then tan x is equals to 1. So x is an arctan 3, and then x is equals negative pi all over 4. Finally, because tan x has a period of pi, he obtained the general solution by adding multiple of pi. So x arctan plus n pi and x is equals to negative pi all over 4 plus n to the pi, the general solution. And then where n is an integer, you can use a calculator to approximate the value of arctan 3.